Hi everyone, good evening.
Good evening.
Good evening, sir.
Okay, so before that, let me share my screen. I just want to tell you something. So here you see, this was your syllabus. Okay, so we had worked on you just go through with the first module till till 11 module. So first to 11 module we have already covered. Okay, first to 11 module we have covered. Now we had to start with the module number 12. From there, we'll be starting this spot check machine learning algorithm. But before discussing this spot check algorithm, what I'll do, I'll just start this deep learning primer. Okay, I'll just start this deep learning primer. And since, we have already worked on the machine learning part, and not only this, we have worked on the several feature engineering and the data cleansing also. So what is my requirement now? We have already worked on the 11 module. Now this 9 modules we have to complete. And I think it will not take more than 2 weeks. Yeah. So what is my, what is my planning that within this 2 weeks, we will be completing 2 projects. Although I understand that it will take time, even if we will be able to complete 1 project, that will be very good. Okay. But why I am telling you that you have to work on these 2 projects and you have to complete it, because right now when we'll be in the learning phase, yeah, then obviously, especially I'll be having time for you. Once your curriculum would have been over, then after I'll not be getting time, yeah, to complete your to give to discuss on this. And even not to worry, even after the completion, of course, we can discuss once in a while, once in a week. But before completion of this course, at least you people have to complete 2 projects, or 1 project should be completed, and second project where before after some suggestion you would have completed it. Yeah. So the first project, what I'll do, I'll just give how many participants are in this there. So there are let me consider it as 26 or 27. So what I'll do, I'll just split, I'll just have these 5 batches. So the entire batch I'll be dividing them into 5 groups, and in each group there will be 5 to 6 people. This division will not be done by myself. This will be from your side. So after this class, you need to connect yourself. How you're going to do that, I don't know, but you have to manage it. And then you will be creating your group where the 5 to 6 people will be in one group. And you will have to tell me also that who will be leading this group. Second thing, if you will not do it, I'll be sharing the Google Sheet on tomorrow at 11 a.m. Tomorrow at 11 a.m., you people will be filling this Google Sheet where one team lead will be there, and his responsibility will be to mention his or her 5 members. If you would have not done this, then I'll randomly pick the participants and fill this Google Sheet. I'll randomly pick, to be very frank. I'll randomly assign tomorrow in the class that who is going to be in which group. And after that, what will be happen that for first three group, I'll be assigning the classification problem. And for another two, I'll be assigning the regression problem. Okay. And their responsibility will be to complete this classification. These three groups' responsibility will be to complete this project within the week. Means in the 7 days, they have to complete this. And they have to complete this regression within the 7 days. After 7 days, what will happen? This will be swapped. Means all those groups who were working on the classification problem, they will be working on what? Regression. And then those who were working on the regression, they will be working on the classification. In this way, for the 14 days, you people have to complete these two projects. Data I'll be giving you, don't worry. But why I'm giving you the same data? Because suppose these two group has worked on the regression and these three group has worked on the classification. So what will happen? Now, when they will be working on the regression, and if you will be finding any problem, then these two group will become their helping hand. And when these two group will be working on the classification, then, and if they stuck anywhere, then these three group will become their helping hand. Okay. Yeah. And you know, whatever we learn, if you want to learn 100%, then 60% you learn from the classroom learning and 40% you learn from the project. So you people have to work on it. And guys, take my words. This is your responsibility. This is your area of interest. This is your point of concern. If you will not be showing the interest, I'm not going to push you. I'm not going to push you. I'll be completing my syllabus. But yes, whenever you'll be discussing, you'll be trying to discuss this, I'll always be available. Take my words. But if you'll not show any interest, then don't expect anything from my side. I'm not going to push you. I'm not going to knock you that what is the status of project. Please tell me. Please tell me. No. I just ask only once. What is the status of the project? If you say that no, we have not started it, it's your job. If you're saying that, sir, I've started, but I'm just stuck in this year, we can discuss them, and I'll be very happy to discuss it. Okay, everyone. And see, this is where I'm talking about the professionalism. But if you ask me, then I'll tell you that this project is very, very important. Because somewhere while working on this project, you would have revised each and everything. And when you will be starting this project, if you remember, I have talked about the CRISP-DM methodology, where you'll be starting from the first stage, then you'll be just try to write the business objective of your business problem. Once it is done, then you'll be working on the data collection. So you will have already data in the hand. Then this third stage where the data cleansing and EDA and feature engineering will be there. You have to thoroughly work on it. So what you can do here, say that you are total 5. Total you are 5. So first 3 can work on the cleansing and the other 2 can work on the EDA. And you will be cooperating to each other, you'll be communicating to each other. And once this is done, then you will be having the model building and evaluation. So my dear friends, when it comes to this model building and evaluation, then what you people have to do, at least 5 model or 4 to 5 models you people will be trying. You people will be trying with 4 to 5 models, and then you'll be doing comparison of it. Whichever model will be doing best, that will become your final model, and that final model you'll be deploying. Okay, and this deployment will be done using Python Flask. And not to worry, Tomorrow, first of all, I will tell you how to deploy your model. Okay, how to deploy your model. So that once your model is built, once you are done with each and everything, then you could be able to do its deployment. And my dear friends, this deployment is really very easy if you understand it. If you don't understand, then nothing can be tough more than this deployment part. Okay, so I'll be covering this tomorrow. I'll be covering this each and everyone. First of all, allow me to complete entire step. Then wherever you will have any issue, please note it down at that time and ask me. And again, I suggest you guys, I'm not telling to everyone, but yes, there are few people. What is their habit? They have the habit of asking question rather than learning first or listening first. So first of all, tomorrow allow me to complete each and everything in the deployment, and wherever you stuck, just ask me that question. But first of all, try to mug up all those steps that I would have told tomorrow. Getting my point, everyone?
Yes, sir.
Yeah. So now the ball is in your court. You people have to tell me the name of the members in your group. I'll be sharing the Google Sheet either tonight itself or in the morning, and you people have to fill it. There only the serial number will be there, name of the team lead, name of the group members, and the project on which you are going to work on classification or regression. And before sharing this Google Sheet, tonight itself, I would have shared you the drive link for the dataset for the regression, as well as dataset for the classification, so that you'll be getting some help to decide that what project you're trying to work. Okay, and again, I tell you, if the first three, if they are working on the regression, then next time they have to work on the classification. So you have to work on this both. Yeah. So whether a classification you are starting or whether regression you are starting, that is not going to be bothered. Yeah, everyone. Okay.
Yes, sir.
So this is the thing that I had to deliver, because whatever you have learned, until and unless you're not applying them into your, project. So the entire things in a particular sequence will not be completed. Okay. So this is all about the project that you have to work. Now let me start this deep learning primer.
Excuse me, sir.
Yeah.
Sir, for deep learning, do we require some amount of GPU, sir? Because I'm on a Mac, I don't have I don't have a good graphics card.
So no, not to worry about it, because this deep learning will be working on the Google Colab. This deep learning will be working on the Google Colab, because whenever you have to work on the deep learning, you require GPU. Just to work on the TensorFlow and Keras, you require GPU. So, this GPU costs very high. And for that sake, what we will do, we'll just use this Google Colab, where we'll be taking the facility of GPU from the Google server, from the cloud. Okay, so that won't be an issue. Don't worry. Now, let's talk about this deep learning primer.
Excuse me, sir.
Yeah.
Sir, I wanted to know that when this project will be given to us.
Uh, Today itself, I'll be providing you the data, means drive link from where you can download the data.
Okay.
And tomorrow onwards, from tomorrow itself, we'd have started to work on it.
Okay, sir.
Okay.
Yeah.
Mm, hmm. Yeah. Okay. So first of all, the question arises why we started to work on deep learning, because we had already a lot of algorithm that were already used to work. Then why we have moved to this deep learning? So basically, the purpose is that there are some limitation in the machine learning. One, this machine learning cannot solve some crucial problem. Like if you will be working with the NLP, then there your machine learning algorithm will become less effective. And if you have to work on the image classification, then except this SVM, none of the algorithm is very efficient. So this is the problem that they carry. And second thing is that, see, if you see this image where lot of background images are there, along with the multiple people, so you will have lot of features. And if you'll start doing them manually, then it will becomes very tedious task. It will become very time-taking process. Whenever this kind of data is there, you always seek to have a automated feature extraction. And the problem with the machine learning is that it lacks here. It does not allow the automated feature extraction. In another way, I can say that you will be responsible to do the feature extraction. Getting my point? So just to work with the complicated problem, as well as just to have this automated feature extraction, we are here for discussing this deep learning. Now the question arises, what is this deep learning? So deep learning is exactly where you're going to mimic the working of a brain. And what is the smallest unit of a brain? Anyone? What is the smallest unit of the brain?
Neurons.
Exactly. This is the neurons. So we will be basically utilizing the concept of the working of the neuron. And since the unit of this brain is the biological neuron, but that we will be using, it will be artificial neuron. Yeah, that will be artificial neuron. And this artificial neuron is actually called as perceptron in our case. So this artificial neuron is called as what? Perceptron. Okay, now you see, this is a neuron, and these are what? These are the dendrite. If in the computer term I say that these are the input sensors, these are the these are the input nodes, and what is their responsibility? Just to take input. Yeah. So whatever stimuli they get, in our terms we say that input. And what is this orange color? This is the nucleus, whose responsibility is that whatever stimuli that dendrite takes, they process it. Okay, they process it. And then after, what happens? This will be the axon terminal. This axon terminal is what? It is your output terminal, whose responsibility will be to provide the output. And these axons are what? Their responsibility is to carry this input, just to transfer this input from this place to output terminal. So this concept we will be using in our artificial neuron. Yeah, this concept will be using in this artificial neuron. And see, this is the building block or the block diagram of the artificial neuron. And I'll just discuss this in my turn. Please try to understand here. Say that these are the input nodes. These are the input neurons. Okay. So how many neurons will be at the input layer? The question arises, how many neurons will be in the input layer? It will be depending upon the number of features you have. And the number of features means how many input column you have. So depending upon the input number of input column, the number of nodes are decided at the input layer. Say that these are X1, X2, and X3. Okay, so you can, these are actually the dendrites. Now, this is your nucleus. And this nucleus will have two things. One is called integration function. Another is called as activation function. Okay. So these nodes are connected to this nucleus. And this is your output terminal Y. And this perceptron that we are talking about, it actually works on the linear problem. So you know what is the equation of a line? Anyone? What is the equation of a straight line?
Y equals to mx plus c.
X plus C.
Y equals to mx plus c. Guys, can I write it as y equals to beta naught plus beta 1x? Or y equals to beta 1x plus beta naught? Where you just consider this beta naught as a c and beta 1 as slope or the m. Okay. Now, here what happens, these are the input nodes, and all these input nodes are associated with the weight. Associated with the weight. Okay. So if I consider this, then can I say that it has becomes now y equals to w, and you know, what is the job of this integration function? It will just sum up them. It will just add them. So before applying this integration function, you will have w1x1, w2x2, and w3x3. So what will be the job of this integration function? It will add them. It will add them. So guys, can I see it as an equation of a straight line? Can I see? Can I say this as the equation of a straight line? Anyone? Obviously not. Why?
Constant.
Yes, because this intercept is missing. Yeah, that C part is missing. Okay, so just to fulfill that, what we will do, we will add another input neuron. We'll add another input neuron, and I'll be writing it as x naught. And its value I'll be assigning as 1. Why? Because here the weight that I'll be giving, it will be b. And you know, if we'll multiply this b with 1, what will be the value? B. So now if I add here b, that is the bias. Can I say that now it has become the equation of a straight line?
Yes, sir.
Yeah. So the job of this integration function is to add them, and the job of the activation function is to process them. The job of the activation function is to process them. Say we are using this, and so we can, as an activation function, we can have ReLU, we can have sigmoid, we can have TANH. But mostly we use ReLU, and let me tell you the job of this ReLU, for example. So how it will be doing? It will be returning f of x equals to 0 if the x is less than or equals to 0, and f of x equals to x when x is greater than 0. So this is the job that a ReLU activation function do. In the same way, there will be a multiple activation function, and every activation function will have their own kind of job that they will be doing. And you know why we are using this activation function? Just to process this input. Just to process this input, we will have the activation function. I hope you understood. Okay, next. Next. So once we process this input, we are going to get the output. Isn't everyone? We will be going to get the output. Now, whenever we will have this output, that will be the predicted output. Say that this is my actual output and this is my predicted output. And if you're working on the regression, then say that this is my first row, first actual output, and this is my first predicted value. This is my second actual output. One second, guys. Okay. Now, say that this is your second predicted output. In this way, say you have the n number of rows, and so obviously you will have n number of prediction, everyone. Now, when you subtract the actual value minus predicted value, what you get? Anyone? When you subtract this actual value minus predicted value, what you get? Error. So can I say that we'll be getting error at each row? We'll be getting error at each row. So the error at each row is called as loss function. The error at each row is called as what? Loss function, and the overall error is called as cost function. So you get my point? The error at each row is called as what? Loss function, and the overall error is called as what? Cost function. Now my question to you all, do you want to have less error or high error?
Less error.
Obviously less error. It means I can say that you want to have high accuracy. Okay, second thing. Initially, these weights are randomly initialized. Okay, and what is your objective? You just want to get the maximum accuracy or minimum error. For that purpose, what you do, suppose you got some accuracy and you're not satisfied with it. So what you will do, you will just go back. You'll just go back and update the weight. Please mind my words. You will just go back and update the weight. So going back and updating the weight is called as back propagation. Going back, updating the weight is called as back propagation. And please again mind my words. Going back, updating the weight so that your accuracy could be maximized. Going back, updating the weight so that your accuracy could be maximized. It is the optimization technique. And for that purpose, we just use gradient descent algorithm. So what is this gradient descent algorithm? So what is this gradient? What is this gradient descent algorithm? Please again. Going back, updating the weight, process this updated weight so that your accuracy got maximized or your error got minimized. And that is done through what? This gradient descent algorithm. So I can say, guys, that this gradient descent algorithm, so a back propagation algorithm is what? It is the subset of this gradient descent algorithm. Can I say it? Because this back propagation is responsible just only to update the weight, while the gradient descent algorithm is responsible to update the weight so that your accuracy could be maximized after processing the updated weight. Okay, next. So how this weight is updated? How this weight is updated? So we have the new weight, and this new weight will be updated on the basis of what? You just take the older previous weight plus eta, that is the learning rate, into the error, into your x, means your input. So you know that you cannot change this weight because you are taking the previous weight. You cannot change this error because it's a subtraction between your actual and predicted value. You cannot not change this x sign because this is the input at that particular row. So can I say that the updated value of the weight, the updated value of this weight is depending upon what? This learning rate. Guys, I just need your response. So this,
Yes, sir.
yeah, updated weight is depending upon this learning rate, and this learning rate value lies between 0 to 1. When we work on the optimization, whenever we work on the optimization, say that this one is there. Like okay. Can I say that this is my global minima? And this is my
Yes,
local
sir.
minima, isn't? And we always try to reach on the global minima. We always try to reach the global minima. When we'll be taking the learning rate equals to 0 or near to 0, what will happen? If I'll be keeping this learning rate equals to 0, then what will happen? This entire term will become 0. Because we are multiplying all the with the learning rate. Since this entire weight will become 0, so what will happen? This Wn plus 1 will become the Wn. And just because of that, what will happen? Just to reach from this local minima to this global minima, we will require infinite number of steps. We will require infinite number of steps. So this is the problem. Next, when we will be keeping the learning rate equals to 1. So what will happen? Instead of reaching to this global minima, we might reach on next, or another local minima. And that is called as overshoot of the minima. And that is the reason why neither we take value of the learning rate near to 0, nor we take near to 1. We always try to get the value of this learning rate near to 0.5. So that neither will have chance to get the infinite step to reach to the global minima, or nor will have chance to reach to any another local minima. Getting my point, everyone?
Yes, sir.
Yes, sir.
Okay. So this is the way how we just update the weight and the importance of the learning rate. Okay.
So that means the optimization depends on the eta.
That learning rate. This learning rate is really very important. I'm not saying that these are not important, but yes, they will have constant, constant contribution. While this will have dynamic contribution. When you'll be taking the value near to 0, you may have the infinite step. When you'll be taking near to 1, you may reach to any another local minima. So you'll have to decide the eta value, which will be experimental. We'll be deciding with the multiple value of eta. Why? Just to get the weight. Why? Because your accuracy is somewhere depending upon the processing of the weight that is going to be multiplied with your input. Understand everyone?
सर जी तो ये प्रोसेस बार बार रिपीट करोगे ना?
हाँ.
क्योंकि पहले बार में जो एरर कैलकुलेट करेगा
क्या नाम है आपका? सौरभ नाम है ना? सौरभ नाम है?
सुमित
क्या?
सर.
सुमित. हाँ सुमित, ये कॉन्टिन्यूअस प्रोसेस है. ये कॉन्टिन्यूअस प्रोसेस है. इसका मतलब क्या होगा? आपके वेट ये कई बार अपडेट होंगे. ये वेट आपके कई बार अपडेट होंगे.
सर ये जो एरर है ये भी तो बार बार बदलेगा ना?
दोस्त, अपडेट करने का पर्पस क्या है? ये जो वेट है इसको अपडेट करने का पर्पस क्या है? सो दैट आपकी एक्यूरेसी इंप्रूव हो और आपका एरर मिनिमाइज हो. और ऑब्वियसली इसका बार बार एरर बदलेगा तो आपका कॉस्ट फंक्शन भी बदलेगा. उसी कॉस्ट फंक्शन से तो आप डिसाइड करोगे ना कि मॉडल कितना इफेक्टिव है.
हाँ सर समझ गया.
आइए समझे सुमित? ओके.
हाँ सर.
आप समझो मेरी बात.
Sir, can you please explain again after you wrote that equation because I was disconnected from the meeting.
Okay, no issue. I'm telling you that whenever you'll be getting this accuracy, might be that that accuracy will be low, or according to you, you're not satisfied with this accuracy. So what you will do? You'll just go back, update the weight. So going back and updating the weight, it is called as what? It is called as back propagation. You're going back, updating the weight, it is called as back propagation. You are going back, updating the weight, processing it, henceforth, your accuracy got maximized. Your error got minimized. It is called as optimization, and the gradient descent algorithm is the example of this. And how the weights are being updated? These weights are being updated by using this equation. And I was telling you that when you have to decide a new weight, its value will be depending upon the previous weight that is fixed. It will be depending upon the input that is fixed. The error you got from the actual minus prediction, so it is also fixed. The thing that you can change for the multiple time, it is a learning rate eta, and the value that you take the value you take from between the 0 to 1. Okay, you take the value between 0 to 1, and if you will take the value near to 0, you may require infinite number of steps to reach to the global minima. And if you will take the value near to 1, then you may reach to any another local minimum. So this is the thing that we were discussing. So always you try to get the value of eta near to 0.5, so that neither you will have chance to reach to neither you will have chance to take infinite step, nor you will be reaching to the another local minimum. Okay.
Okay, sir.
Yeah. Now, when it comes to this gradient descent, so whatever optimizer will be taking, this optimizer will be either taking the concept of the stochastic gradient descent, or they will be taking the concept of the batch gradient descent, or they will be taking the concept of the mini batch stochastic gradient descent. Before that, let me tell you two terms. One is called as epoch, another is called as iteration. Yeah, one is called as epoch, another is called as iteration. So, what is epoch and iteration? See, how many weights are here, everyone? These four? These four? When you will be when you'll be updating each weight, when you'll be updating each weight means you'll be updating the value of B, updating the value of W1, updating the value of W2, updating the value of W3. So when one weight will be updated, when individual weight will be updated, it will be called as one iteration. So if these 4 weights are updated individually, so how many iteration has been taken?
4.
4. Okay. Now, once all the weight has been updated once, when all the weight has been updated once, it is called as epoch. So what is the one epoch?
Sorry, can you repeat that?
Yeah, I'm going to repeat. What is one epoch? One epoch means when whatever weights are there, when all the weight got updated once, your one epoch has been completed. That means if you're writing 5 epoch, so what is the meaning of that? Your all the weights will be updated for 5 times. While when each individual weights get updated, we say that one iteration has taken place. So in this case, since we have 4 weights, so when they got individually updated, we say that it is one iteration. So since 4 weights are there, so 4 iteration took place. And when all these 4 weights got updated, we will say that one epoch has been completed now. Okay, everyone? So this is called as stochastic gradient descent. This is called as stochastic gradient descent. Now, in the batch gradient descent, what happens? In the batch gradient descent, all these weights are grouped into a single group. All these weights are grouped into a single group in such a way that for the outsider, they looks as a single weight. For outsider, they looks as the single weight, and that's why in the case of batch gradient descent, just to complete one epoch, only one iteration takes place. Got my point? Although in this group, in this batch, there are 4 weights. Although in this batch, there are 4 weights, but they are grouped into one batch. And that's why just to update all these 4 weights, we will take only one iteration. Now, guys, if I ask you, suppose you have 1000 rows. You have 1000 rows. So just to complete this stochastic gradient descent, what will happen? In this stochastic gradient descent, since 1000 rows are there, so thousands iteration will take place to complete one epoch. And in the batch gradient descent, what will happen? These 1000 weights are grouped into a one batch. And that's why just to update these 1000 weights, we will have only one iteration. But in this mini batch stochastic gradient descent, what happens? Neither we will be taking the concept of stochastic, nor will be taking the concept of batch. Either will be taking the concept of both. So suppose again we have this 1000 rows, and what we did, we just created the batch, and in each batch there will be 100 rows. In each batch there will be 100 rows. Okay, so how many iteration will take place? So it will be decided on the number of total rows, upon the number of rows in one batch, the number of rows in one mini batch. So what is the total number of rows, everyone?
1000.
1000. And what is the total number of rows in one mini batch? 100. So what will be the total number of iteration for one epoch?
10.
10.
10. So this is the mini batch stochastic, and I tell you one thing, guys. In industry, we use this mini batch stochastic gradient descent. Okay, now one very important thing, just last important thing I'm going to discuss today, that is called as, see, what will be in the output layer. Yeah, what will be in the output layer. So in this output layer, what we decide, the total number of neurons, what will be the activation function, and what will be the loss function. So when your Y is continuous, then the number of neurons that we take, it is 1. And the activation function we take either linear or ReLU. And the loss function we take mean squared error or the root mean squared error. Okay, mostly we take this mean squared error, but we can take root mean squared error also. But when your Y is discrete or the categorical having 2 categories, in that case, the number of neurons will be either 1 or 2, depending upon your problem. Even in the most cases, we'll have 1 for each category. Yeah. So whenever we'll have the Y categorical or discrete having 2 categories, so the number of neurons will be either 1 or 2, and the activation function will be using sigmoid or tan H. And the loss function will be using binary cross entropy. While if the Y is categorical and having n number of category, so the number of neurons will be what? N. And the activation function will be softmax. And the loss function will be categorical cross entropy. Okay, everyone. So the loss function will be categorical cross entropy. Suppose we are working to classify handwritten digit. So how many unique digits are there, everyone? 10? So that means the number of neurons at the output there will be what? 10?
10.
If you are going to classify alphabets, the images of the alphabets are given there. So how many class classification it will be? 26. So the number of neurons at the output layer will be what? 26. So guys, please take a screenshot of this. Please take. Yeah. And whatever we have discussed together today, it is actually called as deep learning primer. Means whether you'll be using the artificial neural network, whether you'll be using the convolution neural network, the output layer will be defined in this way only. And I'll show you tomorrow. Okay, so what we will do, guys, first of all, we'll just complete this artificial neural network. And after this artificial neural network, I'll show you how the deployment is done through Python Flask. And then after, I will start CNN, the convolution neural network. Okay, everyone. So whatever I had told you today, please do it. First of all, please make your batch, make your group, and update the Google Sheet, decide the project, start working from tomorrow. And wherever you stuck, you can ask me either by dropping a message in the WhatsApp, or you can ask me in the class itself. All right, everyone. So let's stop today, and we'll discuss tomorrow the artificial neural network. Okay.
Thank you, sir.
Okay. Thank you, everyone. Thank you so much. Bye-bye. Take care.